By separating code deployments from feature releases, LaunchDarkly enables you to deploy faster, reduce risk, and iterate continuously. Over 1,500 organizations around the world use LaunchDarkly to build, operate, and learn from their software. Find out more at launchdarkly.com.
Hello and welcome to the InfoQ podcast. On today's special episode, we have a panel to discuss this year's trends in artificial intelligence, machine learning, and data engineering. In this trend report, we are going to talk about deep learning, edge deployments of AI models, commercial robot platforms, GPU and CUDA programming, natural language processing and GPT-3, machine learning deployment using containers and Kubernetes, and last but not least, MLOps and DataOps. But before we do that, let's introduce the speakers for today. My name is Roland Meertens, and I'm an editor at InfoQ and product manager at Anatel, working on data for self-driving cars. I am joined here today by Srini.
Thanks, Roland. Hi, everybody. My name is Srini Penchkala. I am the lead editor for AI, ML, and data engineering community at InfoQ. My recent experience has been in architecting and designing and implementing software solutions for data management applications, especially in data analytics space, using technologies like Apache Cassandra, Spark, and streaming frameworks like Apache Kafka and Pulsar. So great to be part of this panel. Thank you.
I am also joined by Anthony.
Hello, I'm Anthony Alford. I'm an editor for the AI and ML space on InfoQ, and I'm also a senior manager of development at Genesis. We're working on cloud-based contact center software.
Thank you. I'm also joined by Rex.
Hi, my name is Raghavan Srinivas, but I go by Rags, and like everybody else in this panel, I'm also an editor in the AI and ML space. I've done some work in big data in general and also in the AI and ML space. One of the panels that I wrote very early was about what is the difference between DL, ML, AI, big data, and so on. And, I still find it very useful to kind of fall back to it, especially as a developer who's kind of trying to understand the space. Glad to be here.
Thank you. And we have a special guest, Kimberly.
Hi, my name is Kimberly McGuire. I'm currently a developer at BitCraze, which is currently developing the Crazyfly quadcopter. And my background is mostly within robotics. And the last few years I did my PhD in gaining autonomy on edge devices, namely a very, very lightweight quadcopters. And thanks for having me here.
Great. Yeah, thank you all very much for being here. Shall we just get started with the first topic of the evening, which is deep learning, which we think is moving to like an early adopter thing. Does anyone have thoughts about the latest trends in deep learning and frameworks?
Well, I can start out. One of the things that we definitely notice is there are two major players in the deep learning framework space, and that's, of course, PyTorch, which came out of Facebook, and TensorFlow, which came out of Google. And an interesting trend alongside that is that PyTorch seems to have become the dominant player in the academic research space versus TensorFlow is the leader in the commercial or enterprise space.
Yeah, you're right. But does it mean that if you want to learn more about deep learning, should you start with PyTorch and then later move to TensorFlow, or should you have a preference for one over the other?
I don't know that a preference necessarily is required. It looks like both frameworks tend to stay fairly even in terms of features and roadmaps. I think either or is probably okay. That said, I do hear people say that PyTorch is a bit easier to pick up. And it may come down to what are your requirements in terms of production performance, being able to operationalize and maybe scale your training and your inference.
So kind of a related question there is, if I'm a developer, and I've already made my investment in PyTorch, is there any way I can transfer my models to TensorFlow or vice versa, right? Efforts ongoing from, I think, Facebook and Microsoft, ONNX framework. How far along is it? And is it really feasible to be able to go from one model to another? Because I really don't want to be basically stuck to a model, right? No matter how good or bad that particular platform or framework is, right? So I want to be able to simply move my models around and to be able to do that. Is that something which is theoretically possible but not practically feasible? Or where are we in that, evolution?
Yeah, I think that's a good point. You mentioned ONNX, and that is definitely one of the things that we see out there. I think those are especially popular for the case where you've trained a model and maybe you want to deploy it on different platforms. And that's when we get to the talking about AI at the edge, being able to deploy on mobile versus an edge device versus in the cloud with a lot of resources. ONNX is definitely something that we see in that space.
Maybe something I also see is that more and more people or more and more companies are storing their data or collecting data in such a way that it is easy for deep learning to learn things. So in the past, you had different algorithms for different types of data, and nowadays a lot of machine learning projects kind of assume that you're going to use deep learning. So people are storing data in such a way that it's easy for deep learning projects, that features are easy to use. Do you guys also see that?
I haven't really looked at anything in particular there, although I know that, for example, the frameworks like TensorFlow and PyTorch are building abstraction layers to help in that case. And they're including a lot of public data sets in their distributions as well. So that's definitely the abstraction layer over the data set is definitely something that's being built into these frameworks.
Yeah, and in that sense also maybe the size of the data sets. Lately, I think you're writing a lot about this, Anthony, is the training on massive data sets just gives you better results nowadays, and more companies are leveraging that to get better models into production.
That's right. That's one thing that OpenAI found when they researched the power laws of scaling. They found more data. Surprise, more data gives better results. And so what we're seeing is all of these frameworks are building in support for the distributed training, so distributed data parallel training, as well as just model parallel so that you can train even bigger models. So we're starting to see a lot of these frameworks have added into their ecosystem tools for large-scale training, such as Mesh TensorFlow for training TensorFlow models on a very large cluster of machines. Of course, Microsoft has been working on their deep speed framework for PyTorch, and Facebook has their own called FairScale. So we're seeing a lot of that. As the frameworks get more mature, now we're starting to spread out and look at ways to scale the training.
Yeah. So we can basically say that deep learning is moving from innovator to early adopter on the topic map. But then the new topic is large-scale deep learning with also, for example, another framework is Horovod. We can just train on many GPUs, many machines at the same time. I think I also saw that in the presentation of Andrej Karpathy, where Tesla bought thousands of GPUs to do all the training on. I wonder how many other companies have such massive server farms for training their models.
So one of the other things with respect to delineation of these frameworks is it good to kind of work with pre-trained models, models that you don't need to train or models that, you have to train? Because, typically, again, goes back to, how much data you got, right? If you really need a large amount of data to be able to train the models well, and just managing data, that data is a big order, right? So is there any advice that we can give developers with respect to kind of like pre-trained models versus, models that you can train and so on, and anything to note there?
I think that's a very good point. And in fact, if you look at these large language models like GPT-3, which we're going to speak about in a minute, they're essentially, the P stands for pre-trained. So the use case for a lot of applications is you take this pre-trained model that's trained with resources and data sets that you don't have access to, but you can fine tune that for your application or use it as an input into something that you fine tune. And I do think that is definitely a trend that we're seeing now, not only for natural language, but also for vision. We're seeing pre-trained vision models that you can take and fine tune on your specific application.
And especially for somebody who's kind of starting out new in this field, right? You don't want to be, dealing with just about every challenge. At least, you can keep that constant and then worry on, your own problem domain, right? So
absolutely.
For the data part, what I also think is interesting is that Andrew Ng is now hosting a data-centric AI competition where he takes a fixed model and just says, okay, well, this is apparently the model architecture you're using. And then the challenge becomes, how do you make the best data set to train on this model? I think it's really interesting that we're kind of getting to programming 2.0, where instead of defining an algorithm and saying, okay, if this, then that, you basically show examples and say, if you see this example, then this class or this action has to be taken. I think that's a really interesting new way of programming, where you just program by example, by just collecting massive data sets with all the examples which you want to capture. And deep learning just seems to be able to learn it and capture it. So in that sense, maybe the only major challenging is deploying it then later in your data center on the edge. Shall we talk a bit about that?
I was going to say, that's a very good segue.
Yeah, indeed. A nice bridge. Thank you, Roland. Edge deployment, I guess what you can kind of see is like a probably like from last year. Definitely, if you just look at the amount of papers that just mention Edge AI or Tiny ML or something like that, it has definitely increased a lot. So therefore, I think, okay, this is definitely something to talk about as well. So at Bitgrace ourselves, we're working on something that is very lightweight and also is able to hold in deep learning and deep neural network. But I must say that if I look at the users that first are going to start out with it, it's definitely very much of a challenge. If, okay, I've never had any experience with anything like TensorFlow before, and it just starts with that system right off the bat. It's usually a very big gap to go for. So I see that a lot of people are definitely underestimating that gap. But yeah, so I guess like the differences that there are between the different devices, I guess like the ones that you can run on your phone or perhaps a Raspberry Pi, or the ones that are even more smaller microprocessor style, like an ESP microprocessor, or even smaller, can even already run some form of AI. And you definitely see that scale kind of going down now. So like, what do you think, Anthony?
Well, I was going to ask if you're seeing the use of these frameworks like Rags mentioned, ONNX or maybe Cafe2. Those are attempts to take models that were trained, say, on very large clusters or trained in the cloud and to deploy them on the edge. Is that something that you're seeing people take advantage of?
Well, it's like I'm not sure if I've seen those type of models. Mostly, like I would say, the ones that have been implemented on mobile net, for instance, and then actually quantizing those even smaller.
Right. So that was what I was going to ask next. Are you seeing people do things like pruning and quantization, where you take a model, or maybe distillation? So you're definitely seeing that quantization then.
Oh yeah, definitely. At least that's what the Gap A chip that I've been working on myself for the company. Kind of like, okay, you have this tiny ML, like a TensorFlow Lite model, but you still have to do like 5 extra steps in order to make it work on a extreme edge AI device. So that's definitely like more and more levels of extreme. So you have to do more quantization. Probably like TinyML already does that. Maybe it goes from 64 floats to 32 floats, perhaps. And then you even have to make it even smaller to even 8 bits, so that the quantization is really super efficient. And usually you have also another step that kind of takes the model that you have quantified and perhaps distributed it over the memory that you have. Like if you have a multi-core system, of course you have to kind of cut it up and implement in such a way that you're able to do it in parallel. At least the Gap 8 has that. I'm not sure like the other type of TinyML microprocessors that exist out there. Yeah, so like I think like for instance the Coral, this I think also a product of Google, also has like multi-cores. But for instance the ESP, I have been programming myself with something called the ESPI, which has only a single core, which is already able to do some simple face detection, and that is only kind of the hello world example. So that's kind of like what is going right.
Are you seeing that these models that have been quantized or otherwise shrunk, are you seeing a big loss in the performance accuracy? For example, with the face detection, does the performance drop when you have to shrink these models, or is it good enough that it doesn't really matter?
I would say that's usually good enough, because I think you do have to realize that on these small systems, especially with that deck that I was talking about, has to be carried by a 20-gram drone, let's say. So they cannot really have a very big camera to begin with. So like if you kind of shrink down the resolution of the camera itself, I don't think really the quantification, maybe from like, okay, maybe 8 bits you maybe notice a little bit, for 16-bit definitely not. So yeah, I think that definitely also says about like, okay, the type of sensors that such an edge device is able to handle.
Hey, Anthony and Kimberly, I have a question for you. So outside of IoT and the mobile applications, do you guys see any other use cases where AI and ML are being done at the edge?
Yeah, I guess the only example that I can kind of give is on really small drones. Yeah, so that's at least the immediate research that I see is that lets you, for instance, have a drone that can now recognize the shape of a road and able to follow it, and that's already from a year ago. And now that will probably currently, I guess that will only grow in terms of capabilities. And there was also a gas-seeking drone that has been also released also somewhere last year, and that was even, I think even that was just a simple neural network on an STM32 processor, and that was also pretty impressive. So that's the only example that I go, and that's mostly from my robotics field that I'm currently working in.
Yeah, definitely. I think drone technology has been evolving a lot, right? So in the recent years.
Yeah, exactly. And gaining smaller, and then they become smart as well as the smaller they go.
I think we should call that a AI ML on the fly, I guess, right? So because
Oh,
Yeah.
Yeah, right on the floor.
Srini's got the best joke.
Yes.
I know we're going to get to Docker and Kubernetes in a bit, but do you think, kind of Kubernetes moving to the edge, that's what seems to be where kind of the community is heading. Is that going to help, hurt, or, doesn't really matter, with AI and ML on the edge?
I don't know, Kimberly, do you run containers on these drones? Does it have the resources?
No, they don't have the resources to do that. But I think that's only mostly for the drones that are able to run some kind of Linux on there. These are really C-based, simple firmware, and that's a little bit too complicated to build a framework on there that you can actually do put the container on there. I use the Docker container myself to kind of for the tool chain to even be able to quantify these kinds of things in the first place, because usually these tool chains are not very easy to install constantly. I always have a lot of trouble with that. So I use containers for that, but definitely not on the drones or the chips itself.
At QCon in November, Toshika gave a talk about Audi and their self-driving cars. And she said that they are running Docker on these Audis when they are testing things. So I guess that's as much on the edge as you're going to get.
You mean the car Audis?
Yeah, the car. Yeah, when they are building prototypes of cars at Audi, they are running Docker on those vehicles, which I thought was an interesting fun fact we discovered during the Q&A.
yeah, I agree with you guys.
Yeah, what is edge? Huh? Where does the edge start?
Yeah, exactly. Yeah.
Or the edge end and the cloud start?
In the past, it was really cool to deploy things in the cloud, and nowadays it's really cool to have things running on your own laptop, and then you can call it on the edge and be really cool.
If there's no wire, it's on the edge, right?
Yeah, if it's running on a one-cell LiPo battery, that's only, yeah, something like that.
Yes, I agree with you guys. I think Docker and Kubernetes, I think the next frontier for those technologies is the edge computing, right? I mean, they're popular, but they're still kind of traditional heavyweight infrastructure right now. So I think, yeah, we definitely need a Docker Lite or Kubernetes Lite or whatever, right? I know there is a project called Kubernetes Edge, Kube Edge. Rags, you may have heard about it.
Yeah, K3S. Yeah, it's affectionately called K3S, and because Kubernetes is called K8S, right? So, but I think the points that have been made in the panel are still relevant in the sense that, if you're running it on an Audi car, you have plenty of space to do a lot of containers. But if you're running it on a drone, probably not, or maybe, even running on a smaller device, it's going to be a big challenge. But I think, Srini, you're right, in the sense that I think we'll see a lot of uptick with Kubernetes on the edge, and that is going to automatically kind of make its way into just about every other field, including AI and ML, I think.
Right. Yeah, definitely. Yeah, Linux Foundation has been doing a lot of work in this area, Rags. They have products like Acrano and also Cube Edge, which is different from K3S. They're still in the initial stages, but I believe they're going to be kind of addressing this edge computing and containerization together and so in the future.
Maybe one thing which is interesting is that you also see that people or companies are adapting their hardware. So I think that Apple M1 chip has special tensor accelerators. I think that iPhones nowadays have special chips to accelerate neural networks. So companies are adapting their hardware, their products to support machine learning, which I think is a massive difference from before the deep learning hype, when you just had to work with the hardware you had. So I think we are going to see a lot more in the coming years there. But maybe that brings us to the next topic. Shall we talk maybe a bit about commercial robot platforms, and where do we also see robots coming into our lives?
Yeah, and what kind of sense? In the household? Yeah, I guess where do we want the robots to be part of, and where do we need the intelligence?
Yeah, I think that in the household nowadays, many people have a Roomba already, or at least I have one and my friends have one, because it's just very convenient.
Yeah, I have a Roborock.
Yeah, so there's many different brands. Let's not be sponsored by one yet. No, but so you do see that these devices are getting more intelligent. But I also, in the last year, think it was really the year of Spot, robot by Boston Dynamics, which is now being used by police stations, is being used by the army, it's being used for civilians. So you do see that there's now more and more robotic platforms out there which are doing useful tasks, also used by traditionally not robotics companies.
Yeah, but I guess it's also because the Spot used to be very inaccessible also for research communities as well. But now I think it was ClearPath that now also Spot in their, not curriculum, but so ClearPath, they obviously offer solutions also to research institutes, and they now also offer the possibility for them to get a Spot. So yeah, that's actually pretty cool.
Yeah, speaking of robots, right, I'm kind of excited, to see what the upcoming Olympics are going to kind of show us, how they're going to use robots, right? It's going to be in Tokyo, so obviously Japanese, technologies are big in robotics. So I'm kind of curious to see what we're going to see as part of the Olympics games starting, I think, later this week.
What would be nice is having a robot Olympics where you just
Yeah.
build the fastest robots or the highest jumping robots.
There you go.
And I think with robots, you don't need to worry about COVID-19, right?
Yeah, that's true. They don't get the virus. They get different viruses.
They get different viruses.
Yeah, exactly.
One other thing, I don't know if this is opening up a can of worms, is the self-driven cars. Is that something that we want to talk here, or do we have another topic?
Yeah, I guess they are being used by research institutes to implement, but I guess like my feeling is that it's still like it's kind of having a step back now. And also Tesla said that it was actually a much more difficult problem that they initially thought. So yeah, that kind of like maybe puts back the trust that people have in autonomous driving, which is too bad. But I think, Roland, you're probably more of an expert than I am.
Yeah, I mean, in terms of self-driving, I think that we are seeing massive successes. So we do see that, for example, Waymo has driverless cars on the road now, and other companies are testing with driverless cars as well, right? So that means that you already have a very large confidence in the driving capabilities of your car. And I think now the next challenge is the same old problem in software engineering, and that's scaling. Can you scale to a larger area with your car? And can you prove that it's safe? So it's again about maybe the traditional topics we at InfoQ are normally writing about, scaling software and proving that it always works, making sure that it always works. I think those are now the challenges again in self-driving. I think that if we manage to solve that, we unlock so many things. If we can have delivery robots, point A to point B, transportation, I think it's great. But yeah, these scaling and making sure it works are the massive problems here.
Yeah.
Mm-hmm.
Shall we move on to GPU programming?
Absolutely. So here we are talking about CUDA, and essentially, this has been around for a while, so probably going to be short. But essentially, this is the way to program GPUs, and GPUs, for those who have not heard of GPUs at all, is basically different from CPUs, where CPU use the von Neumann architecture, whereas GPUs are intended to be massively parallel at the processor level, and to be able to deal with that parallelism, or to be able to take advantage of that, you want to be able to do it programming in a different way. So if you're doing like a vector addition, you need to be able to program those, to be able to specify how many threads, how many blocks, and how you do that in parallel, right? And that's really what CUDA programming is all about. And, there are plenty of resources on the NVIDIA side who basically came up with this concept of the GPU, right? And talks about how you can take your regular program and adapt it to CUDA, or to be able to run it on GPUs. I think there is some flack that CUDA gets. There are things that it could probably do. Like, for example, the developer needs to know the number of blocks and needs to have an idea of how to do this. And it's not easy for programmers to pick this up just like that, although there are plenty of resources, like I said. And, despite all that, I think CUDA is here to stay because, GPUs are everywhere. Just about, if you don't have access locally, you can get access on just about any cloud that you want, right? And you can do some really, really cool things with GPUs, obviously. And CUDA is really the way to go. But like I said, I think the evolution of the language itself has been somewhat at the same level as it has been for a long time, right? And maybe there is some opportunity there, to kind of come up with something different there. Those are my thoughts. What do you guys think?
Yeah, I think that the way I heard someone describe CUDA and parallel programming is that if you want to work the land, you could either use a cow or 1,000 chickens. And a GPU programming, or like a normal CPU, is like a cow. It can do very strong things, one thing at a time. And chickens can do only tiny things, but can do 1,000 things at a time. And I think that is a really good metaphor for CUDA programming. You see that NVIDIA is releasing larger and larger GPUs. So I think you can now have A100 instances on Amazon, and you get, I don't even know how many CUDA cores, and you have a massive amount of memory. So I see more and more people move whole databases into GPU memory. So you can do massive operations on your whole database at once. And I think, the biggest success so far in terms of CUDA programming is really TensorFlow and deep learning and PyTorch. which are heavily using it. Did anyone see any other really interesting applications of GPU programming or GPU applications?
No, I think those are good. And I think the analogy of cow and chicken, right, is pretty apt in the sense that, it's very hard to write bad programs for a CPU, because the compiler is going to organize, reorganize, optimize, re-optimize, all that. But it's very easy to write, bad programs for the chicken, right? Because I think the tools are not still there. I think there's definitely an opportunity there to be able to optimize it better.
Yeah, I do see that people are writing Python bindings, which already make it a bit more accessible. But yeah, I don't know, for people listening here, and I would say don't get discouraged, because writing programs in CUDA is, I think, the biggest fun I had since playing around with deep learning. It is really satisfying if you finally have a program which is doing 1,000 things at the same time.
Yeah, also Roland, I think the GPUs are getting definitely more attention in vision related, machine learning use cases, right? Like, image recognition or video analytics, right? So that's where I think their power really comes through, right? So.
And also the whole way of processing data in a parallel way, in a parallel fashion, maybe even specific to deep learning applications. You do see that more and more, we already talked about this before, but more and more devices are having special chips to run things, tiny GPUs, where you can do lots of parallel operations, which is fantastic.
Yeah, I want to ask a question maybe to Anthony and Kimberly, or maybe Rags also. So we mentioned about self-driving cars earlier. So do you guys see these autonomous vehicles being equipped with GPUs, to process the data, more efficiently?
Well, I almost certainly think so. Yeah. We mentioned comparing with the edge, something like a car has way more electrical power to support something like a GPU. So I certainly think that if autonomous vehicles are going to be solved, we'll most likely solve it by throwing compute power at it.
But I think the compute power is not going to be all at the edge for sure. It's going to be centralized as well. So in other words, one of the biggest things that you think about in self-driven cars is how quickly can the alerting mechanisms from everywhere else other than just that edge device help you as well, right? Or the other way around, right? So I think, Srini, to answer your question, I think GPUs are going to make an impact, just about everywhere. But especially in the context of the self-driven cars, I'm sure more and more of the intelligence, the central intelligence, if you will, is going to be in the GPU power. And one other thing I kind of talked about this, changing context a little bit, is that, I talked about Docker and Kubernetes. Docker and Kubernetes also makes it a lot easier to incorporate GPU or CUDA programming because, there is support for CUDA with Docker. NVIDIA has a toolkit that helps you with that. So it makes it a lot easier. If you're smart, like Roland, you're probably going to do CUDA. But, if you're like me, then what I'm going to do is I'm going to use Docker and incorporate the CUDA code from there and still be able to get the same kind of advantages from there.
Yeah, sounds like Rags. That's CUDA as a service, I guess, right? So
CUDA as a service, yeah, if you want to think about it that way. Yeah.
Okay, so let's talk maybe a bit about natural language processing and GPT-3. So, Anthony, you have written a lot of articles on this topic. What do you think is currently going on in the natural language processing space?
Well, one thing that's certain is that people have ditched the recurrent neural networks like LSTM, and the transformer is the clear winner, and especially very big transformers. So, GPT-3 is not even the biggest now. Everybody's trying to train their, one up GPT-3. So the next trend that we're going to see, I think, is attacking problems like sequence length. So right now, these transformer models, they have a maximum sequence that you can input into them, like basically the biggest sentence that you can write as the input. The other one is that they get a lot of criticism for the resources that are needed to train these large models. So, nobody knows for sure, but the estimate is it costs $12 million maybe to train GPT-3. And that was only one of the models that OpenAI trained for that research project. So these models cost a lot of money, and that money is a proxy for energy consumption. So that's a big criticism. The other one is now you've got this giant model with a billion parameters. Inference speed is an issue. So when you input something into that at runtime to try to get an output, it can take a while. So, if you're working on a real-time application, maybe that's not fast enough. And then one more topic is cross-language applications. And so we're seeing a lot of that research where Facebook and Google and these other big players, they're training these natural language processing models with multiple languages at one time. And it turns out that actually helps the performance. So these are all some interesting trends that I've noticed.
Yeah, what I think is especially interesting with GPT-3, you're talking about multi-language processes, but also multiple tasks.
Yes.
So you have one model and it's like an API. It's like a natural language API for whatever you want it to be. So you can use it to make a chatbot, which is one of the things I did. But I also at some point used GPT-3 to correct my spelling when I was learning Swedish. So I would enter what I thought would be a Swedish sentence and it just corrected my grammar. And if I had to build that in the past, it would have been very difficult. But with GPT-3, you just give it 3 examples of correct sentences. And then it understands what it has to do with the next sentence you feed it. I think it's just amazing that you have one model, multiple languages, multiple applications.
Another thing is multiple media types or multiple modes. So lately we've been seeing language plus vision models, and they're all using this transformer. In fact, the transformer is now being used for things besides natural language. They're being used for vision transformers. And we're seeing very powerful and interesting results from these models that combine language and images. For example, OpenAI, again, they trained a generative model where you could give it even a nonsensical text input, like an avocado in the form of a chair, and it'll create several pictures that really do look like an avocado in the form of a chair. It's very surreal, so they called it DALL-E, after Salvador Dali, the surrealist painter. So it seems like the transformer model has taken over in a lot of applications besides just NLP.
Especially the fact that these transformers work with natural language processing and with image processing. What I'm seeing is that apparently, we already said this at the start of the podcast, but if you just have more data and more compute power, your understanding of the world through the eyes of a neural network becomes better. So GPT-3 is already way better than GPT-2 and the first GPT we had in terms of understanding, in terms of text generation. And it's really, I'm now going to wonder so I think that you also wrote an article, Anthony, about Google, who managed to get 3 billion images into a semi-supervised neural network.
Right.
And apparently that really improves the whole recognition of this neural network. It's crazy.
Yeah, and another thing in that same direction, as the models get even better and better, it's going to be hard to measure how good they are because already there are models that outperform humans on certain benchmarks. So for example, the superglue benchmark, there are natural language processing models that do better than people. That said, maybe we need to realize that benchmarks are not the full story, right? Benchmarks are good for comparing natural language processing models, but just because something is great at a benchmark, we're not done. Even things that perform well on benchmarks may fail spectacularly in a lot of ways. And I don't think we need to think very hard for some examples like Microsoft Tay. I don't know if we should bring that up, but these models are very good at the benchmarks because that's the target during training is to perform well on the benchmark, but it doesn't tell the whole story. They're quite good, and they're quite good in a lot of cases, but in some cases they may not be.
I completely agree. And let me look at it from the other side where I was in the early 90s. I was at Digital. Most of the people who are listening to this podcast probably never heard of this company, but, they had the fastest chip at that time and they wanted to show off what you can do with natural language processing, right? And a company called Dragon was used at that time, which is now really the underpinnings for many of the voice recognition. But, to get to the point, when I talk to, Alexa or Siri or somebody, the chances of getting it right is about maybe 50%. My kids think I have an accent. I don't. But I think it goes back to what you were saying, which is like, it might work fine with benchmarks, but really in the practical cases, can we call it done yet? I mean, obviously it's gotten much, 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 much better. So it may be from 60 to 80%, maybe 85, but it's still not quite hitting the benchmarks. Is it lack of data? Is it lack of compute power? Is it lack of what?
Yeah, I think it depends really on what application you're looking at, because right now, if you look at generative capabilities, just kind of the conversational capability of GPT-3 or the text writing capabilities, I sometimes already struggle knowing whether something was written by a generative AI or by a human with mediocre language skills.
I was going to say that it's not the machines passing the Turing test, it's the humans failing it.
I think we even had articles submitted to InfoQ where we as editors were wondering if someone was just getting started with machine learning and had problems expressing themselves, or whether it was an article generated by GPT-3 because it was like switching from topic to topic pretty quickly, being quite superficial, just making some claims, but not really saying why they were true. And I didn't know if it was generated or not. Like, is the human not good, or is it like computer generated? I think that will be a way bigger problem in the future than we are expecting.
Yeah.
Could I perhaps present some kind of parallel? I don't know if it makes any sense, but it kind of makes me think about what DeepMind did with AlphaGo at one point, is that they kind of ran out of good players to play, to make the AlphaGo actually play against. So they made it actually play against itself constantly, by then improving it by winning from the other ones. But with language, that is difficult because, like, what is the game? What is the rules that you win? Like, oh, I've written a very good book, but it's so complex because one person would think another book is better than the other. So yeah.
Yeah, but especially for the writing books, I've been reading some older books lately, and the more poetic books, I wouldn't see the difference between this book or something being generated by GPT-3. And it actually ruins books for me.
Or poetry. It ruins poetry for you.
Yeah, let's say GPT-3 ruined poetry for me because apparently you can generate it.
And soon it will also ruin art and paintings.
Oh, yeah.
Yeah. No, yeah, but that's just something that crossed my mind.
I have a question for y'all. So I've been reading about this new GitHub's Copilot AI pair programmer, tool, right? I mean, it looks pretty interesting. I have not tried it yet, but I don't know, Anthony, I don't know, maybe you. I mean, does it use like something like GPT-3 behind the scenes or under the hood or some similar technology?
Yeah, I have not looked into it that closely. I imagine it is. So most of these text generators do something like that. You give it an input sequence and it tries to complete a sequence for you.
Yeah, this seems to be, kind of more powerful. It basically completes the code for you, given the context and some rules, right? So
I think it is powered by exactly the same architecture as GPT-3. So far, I didn't have a chance to try it. So Ned Friedman, if you're listening, please give me access.
I also signed up for that same Copilot, indeed. I don't have access to it either.
I'm sure Ned Friedman is listening.
Yeah, it's a limited preview only right now.
No, yeah.
There you go.
Shall we maybe move on to one of the remaining or seemingly remaining challenges in machine learning, and that is the deployment?
Sounds good. Yeah, I mean, I can kind of lead off the discussion there. I know Rags already mentioned about containers and cloud platform like Kubernetes. I've been definitely doing a lot of work in this area lately. So Kubernetes has started as a cloud platform for application deployments, mainly web apps and mobile apps API that are kind of stateless in nature and kind of compliant with what they call 12-factor architecture. So they were the first candidates to be deployed to Kubernetes. The advantage with Kubernetes, it supports all kinds of workloads, whether it's an application functionality or data processing like batch processing or streaming data processing or machine learning, right? So it has the support for these comprehensive use cases, and no wonder it has become the standard cloud platform, right? All the vendors are supporting it, including Amazon, Microsoft, Red Hat, you name it, right? Everybody have Kubernetes in their infrastructure roadmaps. So after the applications, I think the databases kind of started using it, like Cassandra and CockroachDB have kind of taken advantage of the cloud platform, right? So you can deploy these databases as containers onto this cloud platform, and you can scale up and down, comes with a built-in monitoring and all that good stuff, right? So the so-called database as a service has become a reality with Kubernetes and other container orchestration platforms. So I think now I'm seeing more and more machine learning solutions kind of getting on the Kubernetes adoption platform, right? So we have Apache Spark that can be containerized and run as a Kubernetes application. And there are also other frameworks like Kubeflow, that's been getting a lot of attention, right? So I want to hear from others, so have you guys used anything AWS SageMaker or OpenShift? And what kind of use case are you using the Kubernetes for in the machine learning space?
Yeah, I think just to add to what Sri talked about, if you think about DevOps, it's just about everybody is doing DevOps. Because even though you may not have a full-fledged CI/CD lifecycle, you still gain a lot of advantage in terms of being able to be more efficient, more productive, and so on, right? And the main thing about the DevOps lifecycle is that you're constantly there is a feedback loop, which is you deploy your application, you monitor the application, and depending on what is happening with the application, you go back and automatically make the changes, deploy it, and if you can somehow keep the human out of this loop, things are going to be a lot faster. And kind of the same idea is what MLOps is as well, is to be able to have that same cycle and to be able to take advantage of how DevOps has just caught the enterprise by storm, right? So maybe do the same thing with ML as well. And obviously the moving parts with ML are a lot more than if you think about DevOps, because there is this concept of you have to first train the model, right? And then you have to deploy the model, and then if some parameters change, if the data changes, then you go back, retrain the model, so deploy it again. And again, the idea is to be able to kind of look at how efficient your model is, how efficient your algorithm is, and to be able to constantly tweak this and so on. So I think Kubeflow, like what you mentioned, Srini, is great to be able to orchestrate some of these. And the nice thing about Kubeflow, again, is that it can be done anywhere where Kubernetes is, right? And to be able to scale and so on. I think, with respect to talking about 12-factor apps, it has evolved to be more data-driven apps, and that makes it even more challenging, right? From an ML and MLOps perspective, right? So I think there is a lot happening in this area. I think Databricks also has like a what is it called? Some flow, right?
ML flow or something else, right?
Yeah, something like that. And it's kind of on the same idea as well, as to be able to deploy your models and train them and do it as automatically as possible. But I think this is an area where I think we'll see a lot of activity, at least in the next couple of years.
How about you, Kimberly? I know you had some experience with containers, right?
Yeah, but not from the point of view of machine learning, unfortunately. I have seen, though, the study that's actually pretty recent is that, okay, from robotics, they released like a ROS container, a Docker image that we actually are running on a Raspberry Pi at our office for testing like packages and seeing how this works. Like every time that somebody does a commit to one of our repositories, it will run it also on the ROS side of things. And that is actually also, yeah, that's quite handy. At least it makes it more easier to kind of get started, to already get like, you don't have to set up the entire environment. You can just get the Docker container and just get started. But yeah, like in terms of machine, I haven't gone that far yet. I kind of just only discovered Docker and containers myself. So yeah, I'm getting there. Maybe it's also good to maybe keep in mind if we're talking about education and machine learning, but let's see if we come to that topic still.
I think all the technologies we talked about today, GPUs and the edge computing, all that, right? I think that kind of comes together with MLOps and Kubernetes. So they are two additional dimensions of providing speed and efficiency to the application developers. Kubernetes provides a scalable, resilient cloud platform that you can run as many containers as you need. And MLOps brings this operational process efficiency to the process and kind of just brings the best culture that the teams can leverage. So there's no manual steps between the machine learning data scientists and data engineers, right? So it automates all the steps, like Rags also mentioned. So it just kind of complements and completes the cycle. So yep.
Yeah, I guess it also kind of comes to the discussion that we had before about like autonomous cars, for instance. That we first talk about autonomous cars and like that they have the GPUs in there, but they need to also be able to respond pretty quickly on somebody jumping in front of the car, of course. And then something like the transformer networks are not going to be fast enough in order to respond to something like that. I would assume, of course, because it needs to be real time. But there are processes, for instance, in autonomous driving that needs to have a little bit more depth to it. Let's say a little bit more cognition to it. So if this is able to also kind of combine both the more quick, more closer to the sensors on the edge and with, more of, and also kind of connect that as well with the cloud modules. Yeah, that is definitely, I guess, like the best of both worlds, as you said.
Right. Exactly. Yep.
Yeah, I can definitely see an advantage in that. Yeah.
So one of the things that in DevOps, it was very simple to make the argument, right? I mean, maybe not simple, but you know that there was this wall between the devs and the ops. In the ML DevOps or MLOps or whatever you want to call it, right? There is this data scientist who's really at the center, data engineers and so on. going to be harder to kind of do this from an ML perspective as compared to DevOps? I mean, would you see the rewards for this maybe further down the road? Is it going to be harder to have the same coming together, kumbaya, right? Of the data scientist, the developer, the system administrator, the ops, and so on, all of them coming together? Because obviously there are more moving parts here, right?
Well, I think that's a very good point. One thing that we've seen in the past, anyway, is a sort of distinction between data scientist and data engineer, where the data scientist is the one who's looking at the problem domain, looking at the data, and applying, I guess, science to try to determine what's a good model architecture, what's good data, all these sort of things. Whereas the data engineer is the person who helps the data scientist figure out, well, how do we set up the infrastructure and training pipelines, deployment pipelines, and things like that. So maybe the data scientist is more like the dev and the data engineer more the ops. And I really think that the trends we're seeing with MLOps is to try to automate away that data engineer, not necessarily eliminate the role, but maybe make it easier for the data scientist to do both roles, just as DevOps was trying to make it easier for the developer to also do the ops role. So I think that's what we're seeing, especially as we get to the next topic about AutoML. But definitely these pipelines and other things that we've been talking about, like Kubeflow and MLflow, their purpose is to help automate that infrastructure of data scientists creating the model all the way to production.
No, it makes sense. I mean, you wouldn't want a PhD scientist like Kimberly or somebody to be installing Kubernetes, right? Although she is perfectly capable. I mean, data scientists or others may not be even willing to go that way. And the idea is let's focus on the problem domain, on the data scientist, and make this infrastructure pretty much standardized or commoditized, however you want to call it.
Yeah, I strong agree.
Yeah, I agree too. So I think that's a good point, Rags, and Anthony. So I think the MLOps is going to be adding more value compared to DevOps, because DevOps includes only the developers and the operations, like two teams, whereas MLOps brings the third community, right, the data scientists. So there is more need for automating the overall process. And also machine learning by nature is like iterative in terms of like how it works. And also we need faster, feedback, cycles. So machine learning is I think is a great fit for, automating, bringing CI/CD into the mix in the name of MLOps.
Shall we maybe talk then a bit about, can we automate even more? Can we automate the whole machine learning lifecycle with AutoML?
Well, that's certainly the goal. Of course, AutoML is so meta. You've like the machine learning is the machine learning how to do something, but we have a data scientist directing it. Well, let's automate what the data scientist does. So Srini and I did a virtual panel talking to several people researching AutoML. And of course, none of them thought there will never be a need for humans. Right? There's always going to be someone who's defining the problem and bringing industry-specific knowledge, translating the business problem into a machine learning problem. But like you talked about, you don't want to hire a PhD to install Kubernetes. You don't need to have your data scientist worrying about, well, I got to try out all these different hyperparameters. So as you probably all know, when you're training a model with machine learning, you have a bunch of different hyperparameters. Like, so maybe with your neural network, how many layers or, how many steps do you do your iteration? What's your learning rate? AutoML, a great application is to try them all. So hyperparameter search is a very common use case. And one thing that we've noticed, especially with the commercial providers, all the commercial cloud providers now have an AutoML solution. Google, Azure, AWS. And along with that, they're bringing in a way to track these different experiments. So they call these experiments. When you run AutoML, tries a bunch of different things. You need to track that. And you need to track the accuracy, the performance of the resulting model so that you can pick the best one. And you can 5 months later remember what you tried and things like that. It eliminates some of the grunt work. And now you can tackle the next problem. Srini, did you have any thoughts on that as well?
Yeah, that's a great point, Anthony. So yeah, you're right. So AutoML kind of automates those routine tasks, right? That we don't want the data scientists to be spending a lot of time manually running the same input data against different algorithms. So these AutoML solutions, for example, like Data Robot or the one from Google. So they all kind of run everything, all algorithms through this data, and they provide the recommendation, hey, this algorithm or this machine learning model is better for this type of data with these features, right? So definitely, I think, yeah, that's a really good addition to the overall machine learning, tool set. It doesn't eliminate the need for the human participation in the machine learning process, but it automates a lot of those routine tasks that we would rather the machines take care of them, right? So definitely a really good innovation in the space. Yes.
I think what it does do is maybe move the importance or move the focus on what is your biggest problem from finding the best model to finding the best data and ensuring that your data is of high quality, your data set is balanced, it contains all the maybe possible edge cases for your application. And I think that's really interesting. I'm really excited to see more on what's going on there in that field in the next couple of years if we have more active learning, etc., to get the best data for your machine learning application where the model can just be found automatically. I think that's great if we as a field manage to get that part away and have a new problem to focus on.
Yeah, absolutely. There's always a trade-off. I mentioned this AutoML can try a bunch of different models out for you. We talked about how much money it costs to run GPT-3. Now imagine the AutoML running that hundreds or thousands of different parallel training jobs on GPT-3. So what we see also is these AutoML solutions try to be smart in their search. So of course, search and restricting search space and optimizing search, that's an old problem. So we're seeing a lot of these things brought into that. And we're looking at things like Bayesian optimization of the search algorithms in AutoML.
Maybe now that we know that soon there will be no more need for machine learning engineers to define models, shall we talk a bit about education of machine learning?
Yeah.
So what do you all think nowadays when you want to start with machine learning? How would you start? Maybe Kimberly, do you have any ideas?
Yeah, for me it's a little bit difficult actually, I would say, because I've had machine learning for at least during my master's. There are quite a few courses, but it's been a long time ago that I actually applied to something. Like the drones that I flew with, they didn't have neural networks in there. Very still simple state machines. So I do have the background knowledge. It kind of like feels like sometimes, like now with this podcast, like speaking Swedish, let's say. I can actually understand Swedish quite well, but I cannot really respond very well. So I definitely have to train my machine learning speech. But if you're not a complete beginner, I feel it's even more difficult to find the right information to get you up to speed. Like, for instance, when you guys were talking about the transformer ones, like back when I was applying machine learning on my master thesis, it was in a neural network with some recurrent connections. And now it's like, that's out of the window. What happened? It's going so fast. So it's a bit difficult, like if you already had the background, like from some kind of past, to really get into it again. So my boyfriend, who wants to get started with machine learning right from the start. And I kind of actually envy that, because then you can kind of really start with those tutorials from the right beginning all the way to the end. But there's no really good sideways for people that already have some kind of background knowledge, but don't want to really start with the beginning.
I think we can all recommend InfoQ.com
InfoQ.
as a resource for learning things.
Yes, I will definitely check it out indeed. But yeah, that's kind of like more my experience, I would say. Yeah.
And like Kimberly, I am a developer. I really don't know much about CNN, DNN, classifications, regressions. I'm not really very strong on statistics either. So I think there are plenty of resources, on the web. And you're right. It's always a tough job to kind of figure out which one works best for you. My undergrad was in mechanical engineering, and I like to see things move. Obviously, doing something with Python notebooks, Google Colabs, seeing things as they evolve, I think makes it a lot easier for me. I think those are some of the resources that I've used. If you go to any of these cloud, AI sites, there are plenty of examples that you can play around, like computer vision and so on. Granted, they're pretty simplistic, but at least it kind of gives you an idea of how to kind of get started and what exactly does regression mean. What exactly does classification mean? You don't have to know everything, but at least, to a point where you can kind of figure out what domain does your problem or what domain is your problem set in, kind of thing, right? So really, I think, if you can go on Google Colab, GitHub, Python notebooks, I think that's probably the best way to do it. And one of the cool things today is that, you can stand up GPUs, multiple GPUs, on the cloud and kind of play around with CUDA programming or anything that you want. So those are kind of off the top of my head. And I'm sure if you look through some of these frameworks such as TensorFlow, PyTorch, Theano, CNTK by Microsoft, Keras, all of them have fairly simple programs to get started with, which kind of gives you an idea of the breadth, right? Of course, going deep in any one area is going to take some time.
Yeah, true. I guess it's also kind of difficult because usually I cannot really let go of the application that I already want to use. Like, for instance, what I want to have right now is already a pre-made mobile neural network that can detect some kind of feature, just train the input layer and turn it to the TensorFlow Lite model. And that's kind of just like, because I already have the specific idea, I know how it's possible, but just like searching for that on any of those tutorials is actually quite a pain. It's possible, but yeah, maybe I just have to kind of let it go and just spend a couple of days, just kind of maybe just a couple of steps back, and let's see just how this tutorial evolves.
Maybe you have to write a model to be able to extract this from the,
Exactly. I put all my trust now on GPT-3.
Maybe one tip for people who really don't have any computer vision or machine learning experience is Google has a website called teachablemachine.withgoogle.com. And there you can super easily train a computer to recognize your own images or sounds or poses. And I think that's a perfect way to introduce not only children, but everyone to train a model. So you can just use your webcam to show it the examples you want to classify. And then you can download the model and load it locally into your own Python or something. So you can really go from collecting data to having a model deployed on your local laptop within, I would say, literally 1 lunch hour. You can have your own machine learning model live deployed. And I think that's a fantastic way to get started. Maybe another tip is to participate in a Kaggle competition. So I think it's really good if you can learn by doing. Then you have some intrinsic motivation to get a higher ranking in this Kaggle leaderboard. And you can try to search all the tips and tricks to improve your model, improve your training. And after the competition, you can even see what the winners, what kind of tips and tricks they have for improving your model. So you are really getting feedback on what you should have done to get a better model.
Yeah, I agree. I found Kaggle very helpful. And I also think if someone is starting out, then maybe the best answer is not to go do TensorFlow and build a deep neural network. Really, just start with something simple like scikit-learn and some linear regression or logistic regression. Because the way I've started talking to, say, quote, regular software developers, unquote, I just tell them machine learning is just something that writes a function for you. So to consume machine learning is 99% no different from consuming any third-party library in your code. Just think of it as a function. And so in your case, Kimberly, you're looking for somebody who's already written that function for you. And I think that's probably the mindset that most people need to have, is just think about machine learning as something that creates a function for you to call. And if you want to learn more, start with something like Kaggle, do some logistic regression on the Titanic data set or something like that. I think that's very helpful for forming the basic understanding, and you can build on that.
Yeah, also, Anthony, as you mentioned, right, there are some frameworks, that are kind of more developer focused, like Apache Spark, but they do abstract all of these complex machine learning algorithms behind the scenes. So if you want to do, like you said, regression, it's just a one line of code in the, either Python API or Java API, right? So those tools can also be a good start for developers, that want to learn more machine learning. But for education discussion, right, I want to kind of come from a different angle here. So to me, if any of our listeners of this podcast are new to machine learning, they want to get into the machine learning space and they want to start a career with machine learning, I think my suggestion is, kind of they need to pick, which type of, machine learning discipline they want to specialize in. I kind of see like 4 different areas, right? They can be a data scientist, or they can be data engineers, they can be data analysts, or they can be data operations side of the responsibilities, right? So once they kind of based on their interest and skill sets and the background, once they pick one of these 4 areas, right, to become an expert in, then I think what you all mentioning, make a lot of sense. If it's a data engineer, we want them to be learning about programs and how to run these different algorithms from the programming side. But if they want to be a data scientist, they need to learn more statistics, that I'm not good at, So, it kind of is a different way of learning, right? So as you all mentioned, there are so many resources available out there, it just the time is the limit, right? So whether it's Google Code Labs or whether it's Udemy or Pluralsight courses, or, most importantly, our own InfoQ has so many different resources, right? So that they can check it out.
I think that is great notes to end on. Read InfoQ and visit QCon. And I think this was a great discussion. So I want to thank you all, Srini, Anthony, Rex, and Kimberly, for joining today and giving these great insights. And the trends report with relevant links and a summary for everything we discussed today is available on InfoQ.com. And I hope you will join us soon for another InfoQ podcast.
Thanks, Roland. This was a lot of fun.
Thanks, Varun.
Thank you.
Yeah, thanks.
Thank you. Great discussion.